Hello everyone, welcome back to the CS again. Today we are diving into some important concepts in first order logic, specifically focusing on interference. We will cover interference in first order logic, the differences between propositional and first order interference, unification and lifting, as well as forward chaining, backward chaining and resolution. So let's get started. First, let's talk about inference in first order logic. Inference is the process of deriving new knowledge from existing knowledge using logical reasoning. In FOL, inference allows us to draw conclusions based on the relationships and properties defined in our knowledge base. For example, if we have the statements for all x of human of x to mortal of x, all humans of are mortal, human of Socrates is a human, we can infer model of Socrates using logical reasoning. This ability to derive new facts is crucial in AI applications, where systems need to make decisions based on incomplete information. Next, let's compare propositional inference with first order inference. Propositional logic deals with whole statements that are either true or false, while first order logic allows us to express relationships between objects and quantify over them. In propositional logic, inference is relatively straightforward. For example, if we know P to Q, if P then Q and P is true, we can conclude Q is true. In contrast, first order inference is more complex due to the presence of quantifiers and predicates. It allows for more expressive statements such as for all x cat of x to animal, all cats are animals. This means that first order inference can handle a wider range of scenarios and relationships, making it more powerful for representing knowledge in AI. Now, let's discuss unification and lifting, two key concepts in first order logic inference. Unification is the process of making two logical expressions identical by finding a substitution for the variables. For example, if we have the expressions human of x and human of Socrates, we can unify them by substituting x with Socrates. Unification is essential for inference because it allows us to apply rules to specific instances. Lifting, on the other hand, refers to the process of generalizing a specific instance to a more general case. For example, if we know human of Socrates, we can lift this knowledge to say for all x human of x to mortal of x if we have the general rule that all humans are mortal. Together, unification and lifting enable us to apply general rules to specific cases and derive new knowledge. Next, let's look at forward chaining, a popular inference technique in first order logic. Forward chaining is a data driven approach where we start with known facts and apply inference rules to derive new facts until we reach a goal or exhaust all possibilities. For example, if we have the rules for all x human of x to mortal of x human of Socrates, we can use forward chaining to infer mortal of Socrates. By applying the rule to the known fact, this method is particularly useful in rule-based systems and expert systems where we want to derive conclusions from a set of known facts. Now let's discuss backward chaining, which is a goal-driven approach to inference. In backward chaining, we start with a goal and work backward to see if we can find the necessary facts to support that goal. For example, if our goal is to prove mortal of Socrates, we would look for rules that lead to this conclusion. We would check if human of Socrates is true if we have the rule for all x human of x to mortal of x. Backward chaining is often used in systems like Prolog and is particularly effective when we have specific goals to achieve. Finally, let's talk about resolution, a powerful inference rule used in first order logic. Resolution is a proof technique that involves refuting a statement by showing that its negation leads to a contradiction. It works by converting all statements into a standard form called conjunctive normal form CNF and then applying the resolution rule. For example, if we have two clauses, human of Socrates or mortal of Socrates, if Socrates is not human, then he is mortal. Human of Socrates, we can resolve these clauses to conclude mortal of Socrates. Resolution is particularly useful in automated theorem proving and logical programming as it provides a systematic way to derive conclusions from a set of premises. And that wraps up our discussion and inference in first order logic, including the differences between propositional and first order inference, unification and lifting, forward chaining, backward chaining and resolution. I hope you found this video informative and that it helps you understand this concept better. If you enjoyed this content, Please give it a thumbs up, subscribe to CSE Guy for more videos, and leave your thoughts or questions in the comments below. Thanks for watching, and I will see you in the next video. Thank you.